When most people think of a snail, they picture a slow-moving animal protected by a simple shell. Hydrothermal vents had other ideas. Deep beneath the Indian Ocean lives one of the most extraordinary mollusks ever discovered, the scaly-foot snail. At first glance, it appears unusual enough. Like many vent animals, it survives in complete darkness among hydrothermal vents, relying on a close partnership with chemosynthetic bacteria. But what made this species famous was not where it lives. It was what it wears. The scaly-foot snail is the only known animal on Earth that incorporates iron into its external armor. Its shell is unusual. Its foot is even stranger. Most snails have a soft, muscular foot used for movement. The scaly-foot snail's foot is covered by hundreds of overlapping scales, known as sclerites. In some populations, these scales become coated with iron sulfide minerals drawn from the chemical-rich environment surrounding hydrothermal vents. The result is something that resembles biological chainmail. It is one of the most remarkable defensive structures ever discovered in an animal. To understand why such armor evolved, it helps to understand the world in which the snail lives. Hydrothermal vents are often described as isolated oases on the deep sea floor. Chemosynthetic bacteria form the foundation of the ecosystem, supporting tube worms, mussels, shrimp, crabs, and countless other organisms. Where energy is abundant, competition follows, and where prey exists, predators inevitably appear. The scaly-foot snail shares its environment with predatory crabs and carnivorous snails capable of crushing, piercing, or otherwise damaging softer-bodied animals. In most ecosystems, shells provide a reasonable defense. At hydrothermal vents, evolution appears to have pushed that strategy much further. Researchers studying the scaly-foot snail discovered that its armor is not simply hard. It is engineered. The shell itself consists of multiple layers with different properties. Rather than relying on a single rigid structure, the shell combines layers that help absorb, distribute, and resist mechanical forces. The iron-containing outer layer provides protection against penetration, while deeper layers help prevent catastrophic cracking. The scales covering the foot add a second line of defense. Together, these structures create one of the most sophisticated armor systems known in the animal kingdom. In fact, the snail attracted attention far beyond marine biology. Materials scientists and engineers began studying its shell because it solves a problem humans have struggled with for centuries. How do you build armor that is both strong and resistant to failure? Too rigid, and it shatters. Too flexible, and it offers little protection. The scaly-foot snail achieves a balance between these extremes, using structures refined through millions of years of evolution. It is a reminder that nature often arrives at solutions long before humans recognize the problem. Yet the armor is only part of the story. Like many hydrothermal vent species, the scaly-foot snail depends heavily on symbiotic bacteria living inside its body. These bacteria perform chemosynthesis, using chemical energy from vent fluids to produce nutrients. In a sense, the snail carries its food source with it. This partnership allows it to thrive in an environment where sunlight never reaches, and photosynthesis is impossible. The animal's survival, therefore, depends on two very different forms of adaptation. Internally, it relies on cooperation. Externally, it relies on defense. One relationship provides food, the other helps prevent becoming food. Together, they allow the snail to survive in one of the most extreme environments on Earth. The discovery of the scaly-foot snail challenged assumptions in multiple scientific fields. Biologists were fascinated by its unusual ecology. Engineers studied its armor, materials, scientists examined its shell structure. Conservationists later raised concerns when some hydrothermal vent regions containing scaly-foot snail populations became areas of interest for deep-sea mining. For a creature that remained completely unknown to science until the 21st century, it has had an outsized impact on how researchers think about evolution, materials, and life in extreme environments. The scaly-foot snail is often described as the snail wearing iron armor. That description is accurate, but perhaps it misses the bigger picture. This is not simply a snail that happens to wear metal. It is an animal living beside undersea volcanoes, farming chemical energy through microbial partnerships, and defending itself with one of the most sophisticated armor systems evolution has ever produced. In the darkness of the deep ocean, it transformed the chemistry of its environment into a suit of armor. Few animals can make that claim,